In this example, we are going to use the scaffold-based library enumeration feature in the Nova module in StarDrop, in combination with R group analysis, to generate a virtual library representing a potential new lead series. This will be based on a previous series and explore the impact of a change of scaffold and variations in a sidechain while retaining the substituents at two key positions. Start by opening the Factor 10a StarDrop project. This project contains a series of 78 Factor 10a inhibitors for which we have measured pKi values. First, we'll perform an R group decomposition of this series to generate some R groups to substitute on a new scaffold. Select the first row in the dataset and click the R group analysis button on the right-hand toolbar to open the R group decomposition wizard. On the Select Scaffold page, draw around the fixed scaffold for this series, which will be highlighted in blue. Click Next to confirm that the correct substitution points for R groups have been identified. On this page, you can define additional substitution points or variable atoms or linkers, but we don't want to do that in this case, so click Next again. Finally, we can give this analysis a name for future reference, and click Finish to complete the analysis. The resulting R group decomposition is shown in the dataset. Now we are going to enumerate a new virtual library for a similar series based on an indole core. With the first row of the dataset still selected, click the arrow at the bottom of the Nova area to start the enumeration. In the wizard that appears, select the Scaffold-based Library Enumeration option and click the Next button. The Select Scaffold page will be shown, containing the selected member of the series. You can, of course, sketch a new scaffold by clicking the Reset button, but in this case we'll edit the displayed compound to create the scaffold of our new library. Erase the groups at the substitution points to leave the scaffold for our new series. For small groups, you can use the Erase tool to erase atoms or bonds. For larger groups, use the Select tool, draw around the regions you wish to delete, and click the Delete key to delete them from the structure. Next, modify the core of the original series to change it into an indole. Select the Bond tool and click the bond to change it from single to double. Use the R group button to add R groups in the R1, R2 and R3 positions by clicking on the atom to which they should be connected. We will also define some variations in the scaffold, in this case to the linker between the core and R3. Using the X tool, click on all the atoms that comprise a contiguous region of the linker. Click Next to move to the Define R Groups page, where we can list the groups to substitute at each point. Click the Add button next to R1 and choose Select to open the library of predefined substituent groups. In the fragment library, you will see that the groups derived from the R group analysis of the original series are available. Clicking the arrow next to an entry will expand the list to show the individual substituent groups in that list. The metadata options below enable you to specify which data from the fragment library are added to the enumerated library dataset. This can be valuable if you have associated reagent IDs or inventory information with each fragment. Tick the box next to the list of R1 groups from the original series to select all the same groups for the R1 position on the new indole scaffold, and click the OK button. Now click the Add button next to R2 and choose Select. Choose the list of R2 groups from the original series and click OK. Now scroll down for R3. Click the Add button and choose Select. The Indoline library only generated a single fragment to use at R3. Select this and click OK. We will now sketch an additional substituent for the R3 position. Click the Add button next to R3 and choose the Sketch menu option. Draw a 4-chlorophenyl group. The star indicates the attachment point of the R group, so the fragment must link to this point. As you sketch a fragment, StarDrop will suggest other similar fragments that you might be interested in adding. Use Control-click or Command-click on Mac to select any fragments of interest and add them to your fragment list. The first fragment is already defined for X1. This is the linker from the original library. Click the Add button next to X1 and choose Sketch to define an additional fragment. In this case, we want to define a fragment with a longer linker. Erase the bond between the nitrogen and amide carbon and insert an additional methylene. Click OK to add it to the list of X1 linkers. You should see that the resulting library is estimated to contain just over 1,000 compounds. Click Next. If we wish, we can automatically calculate the properties of the compounds in the resulting library and select a subset of compounds according to a given property or score. In this case, the library will be quite small, so we could easily enumerate all the compounds, but as an example, we will select the 100 compounds with the lowest predicted log P for further analysis. Check the Select Compounds option. Choose the selection method property and select compounds with low log P. Now choose to select the best 100 compounds and click Next. Finally, on the Enter Dataset Name page, we can give the resulting library a name and click Finish. In the Nova area, an indicator will show the progress as the library is enumerated, the log P calculated, and the compounds selected. When complete, the resulting library will appear in a new dataset in StarDrop, and all StarDrop's capabilities can be used to select compounds or consider further improvements. This example shows how we can use the scaffold-based library enumeration feature in StarDrop's Nova module in combination with R group analysis to generate a virtual library representing a potential new lead series. For more worked examples of other StarDrop features, take a look in the tutorials section of the Optibrium website.